A white wall rises from the ocean and stretches across the horizon. It looks endless. Is it fog? A storm? No, it's something far bigger, and it's moving. The world's largest iceberg has broken free, and now it's drifting into open waters. Out in the freezing waters of Antarctica, a giant has awakened. Its name is A23A, the largest iceberg on Earth right now. After being stuck for decades, it's finally on the move again, and scientists around the world are watching closely. So what exactly is happening? And should anyone be worried? Let's break it down. A 23A first broke away from Antarctica's Filchner ice shelf back in 1986. But instead of floating off into the ocean like most icebergs, it got stuck. The bottom of the iceberg scraped against the seafloor just a few miles from where it split off. And there it stayed for 37 long years. Because it was grounded, it melted much more slowly than normal icebergs. It was like a frozen time capsule sitting in the same place while the world changed around it. To understand how huge this thing is, imagine a piece of ice about 3 times the size of New York City. It weighs nearly 1 trillion tons. That's not a typo. 1 trillion. In 2023, something changed. Ocean currents and shifting ice finally helped lift A23A off the seafloor. It broke free and started drifting into the Southern Ocean. But the journey wasn't smooth. Not long after escaping, a 23A got caught again, this time in a strange spinning current near the South Orkney Islands. The iceberg was trapped in what scientists call a Taylor column. That's when water swirls around an underwater mountain and creates a slow, spinning vortex. At one point, this giant iceberg was rotating about 15 degrees counterclockwise every single day. Imagine something the size of a city slowly spinning in the ocean like a lazy top. Then in late 2024, a 23A escaped once again. The spinning stopped, the drift resumed, and now it's slowly heading into open waters. The big question is, where will it go? Most giant Antarctic icebergs eventually drift northward into warmer waters. As they move, they slowly melt. Some follow similar paths taken by earlier icebergs. Others surprise scientists and take unexpected routes. Right now, researchers are carefully tracking A23A using satellites. Modern technology makes it possible to follow even remote icebergs from space. That's important because large icebergs can pose risks to ships if they drift into busy sea lanes. But danger isn't the only story here. There's another side to these icy giants. As enormous icebergs melt, they release nutrients trapped inside the ice. These nutrients feed tiny ocean plants called phytoplankton. And when phytoplankton grow, they support fish, seals, penguins, and even whales. In parts of the ocean that are usually low in life, a melting iceberg can create a temporary hotspot of activity. It's like a floating garden, feeding life in empty waters. Scientists are especially interested in how A23A might affect the ocean around it. They've been collecting water samples along its expected path. By comparing water before and after the iceberg passes through, they hope to learn how massive chunks of ice influence marine ecosystems. And here's something incredible. The ice inside A23A could be ancient. As some Antarctic ice is nearly 1 million years old. That means the snow that formed this iceberg may have fallen long before humans built cities or even started farming. In Greenland, the oldest glacier ice is over 100,000 years old. In Alaska, the oldest recovered glacier ice is about 30,000 years old. Compared to Antarctica, that's young. Ice may seem frozen and still, but glaciers are always moving. In Alaska's Bering Glacier, which stretches more than 140 miles, sheet ice can travel from top to bottom in less than 400 years. That's fast for something so massive. When pieces break off glaciers, they become icebergs, and many of them travel through a famous region known as Iceberg Alley. Iceberg Alley stretches from the Arctic down toward Newfoundland and Canada. Every year, between 400 and 800 medium to large icebergs pass through this area. Most come from Greenland. In spring and summer, chunks of Greenland's glaciers break away and drift south through Baffin Bay and into the Labrador Sea. Some continue along the coast of Newfoundland before melting. These icebergs are old too, often around 10,000 years old. They come in many shapes. Some are tabular, flat and wide like giant tables. Others are blocky with steep sides. Some have sharp peaks and are called pinnacles. Dome-shaped ones have rounded tops. There are even U-shaped dry dock icebergs with hollow centers. But each one looks different. Each one tells a story. Most icebergs drift slowly, usually less than half a mile per hour. Wind, waves, and ocean currents control their speed. Warmer water speeds up melting, making their movements harder to predict. In 2018, one giant iceberg drifted close to a small village in Newfoundland. Photos showed it towering over houses like a frozen skyscraper. It became stuck in shallow water and turned into a viral sensation. But sometimes, our icebergs become part of tragic stories. In April 1912, the ocean liner Titanic struck an iceberg in the North Atlantic. The ship sank, and more than 1,500 people lost their lives. Why didn't they see the iceberg sooner? Icebergs don't always look bright white. Some appear gray, some look striped, and under certain conditions, very pure ice can appear almost black because it absorbs light instead of reflecting it. At night, in calm seas, icebergs can be nearly invisible. Without radar, which ships didn't have in 1912, spotting one in time was incredibly difficult. That tragedy changed maritime safety forever. Today, ice patrols and satellites track icebergs to protect ships. Back in Antarctica, A23A continues drifting. It's unlikely to threaten major cities, but it reminds us how powerful nature can be, and it connects to something bigger. As Earth's climate warms, ice shelves in Antarctica are weakening. When large icebergs break off, it doesn't always mean sea levels will instantly rise, because the ice was already floating. But frequent breakoffs can signal stress in the ice sheet system. At the same time, warmer oceans mean stronger storms in many parts of the world. Scientists studying ocean sediment in places like the Great Blue Hole near Belize have found evidence that tropical storms have increased over thousands of years, especially in recent decades. Warmer water fuels stronger storms. Warmer air holds more moisture. The planet's systems are connected. Icebergs, hurricanes, tornadoes. They're all pieces of a much larger puzzle. That doesn't mean panic. It means paying attention. A 23A is not racing toward crowded beaches. It's drifting slowly, following the rules of currents and gravity. Over time, it will shrink. It will break apart. It will melt back into the ocean. But while it lasts, it offers scientists a rare opportunity to learn more about our planet. How do giant icebergs shape ocean life? How do currents guide them? What secrets are locked inside ancient ice? Every satellite image, every water sample, and every measurement brings us closer to answers. And maybe that's the real story here. A frozen giant drifting across the sea isn't just a threat from a movie scene. It's a reminder that Earth is alive, always changing, always moving. So next time you see a photo of a massive white wall floating in blue water, remember it's not just ice, it's history, it's science, it's nature in motion, and we're watching it unfold in real time. If you enjoyed learning about this icy giant and want to stay updated on incredible events happening around our planet, make sure to like this video and subscribe to the channel, because the world is changing and we'll explore it together.